Welcome back, folks. In this video lecture, we'll talk about the Doppler's effect. So before I jump into the formula of Doppler's effect, I want to ask you guys a question. Let's say you're standing on a side of the road and there is a car which is approaching towards you, and you're not seeing that car, but the idea is that car is honking towards you. Will you be able to find out without looking at the car that there is a vehicle which is approaching towards you? Pause this video and think about it. I'm sure you might have figured it out that yes, with the honking of the car, you will be able to identify whether that car is approaching towards you or leaving away from you. And for that, Doppler gave two formulas, and that's literally called the Doppler's effect also. So the formula looks like this: Ft equal to Vw upon Vw minus Vs times it by Fs. And the second formula is Ft equal to Vw upon Vw plus Vs times Fs. This formula is for when the vehicle is approaching you, and this is moving away from you, moving away from you. That's when we use the second formula. Now, we'll talk about the different terms which are used in this formula. So VW is the speed of wind. Okay, this is VW is the speed of wind. S means source. So frequency of the source. So frequency of source. That is Fs. And Ft is the frequency, Doppler's frequency. Doppler's frequency. And this Vs is the speed of source. So for example, if this car is moving at 30 kilometers per hour or 30 meters per second, I'll keep the SI units. So this value will be 30 meters per second. And if car is honking at 340 hertz, so this will become Fs. Okay, and Vw, as I said, it is the speed of the uh, wind. Means the speed of the sound traveled in the wind. My apologies. Speed of the sound traveling in wind. That's what I shall write. That's VW. All right. So based on this, I will try and solve this question. A train is traveling at 30 meters per second. So we are given Vs 30 meters per second. It whistles generate the sound with the frequency is given to me, that is equal to frequency is 30 meters per second, and not 30, sorry, I was distracted for 1 second. 224 hertz, that's what it is. And this will be which one? This will be Fs, source, because it's generated by the whistle. And then you are standing beside the track and the train passes you with the whistle blowing. What is the change in frequency uh, of the whistle as the train passes if the speed of the sound in air is 330 meters per second? Vw is 330 meters per second. And I wanted to find Ft. All right, so when it is approaching, it wants us to find out change in frequency. You detect the pitch of the whistle change in frequency, that's what it wants us to find. So change in frequency means once we will try and find out when it is approaching towards us, and another time we'll try and find out when it is leaving from us, the vehicle I'm talking about. So first of all, I will write down the formula when the vehicle is approaching towards us. So that will be VW on VW minus VS times it by FS. And VW is 330, 330, 330 minus speed is 30 meters per second, speed of the vehicle given to us. That's this one, 30 meters per second. Now, this Fs is 224 hertz. I'm sure you can do the calculation. And once you're going to solve this is going to give you 246.4 hertz. That is when the vehicle is approaching towards you. When the vehicle is leaving away from you, then I will write down the formula Ft equal to Vw upon Vw plus Vs times it by Fs. In this scenario, again, we'll put the same values, 330 plus 30, multiply it with 224, and once you're going to solve these numbers, you're going to get the number as 205.3 hertz. And now the question says to us that find the change in frequency. It's here, what is the change in frequency? So delta ft, that will be equal to 246.4 minus 205.3, and that will come out to be 41.1 hertz change in frequency. So hopefully you understood how we're going to approach these kind of questions. And yeah, that's it from my side. I'll see you with another lecture video. Till then, goodbye.